For centuries, humans have gazed upon Mars, the red planet, with a mixture of awe and curiosity. The allure of this distant world has been a constant source of fascination, inspiring both scientific inquiry and imaginative storytelling. Its rusty hue, visible even to the naked eye, has sparked countless tales of alien life and inspired dreams of one day setting foot on its surface. From ancient civilizations to modern science fiction, Mars has always held a special place in our collective imagination. Today that dream is closer than ever, with space agencies and private companies alike setting their sights on sending humans to Mars within our lifetimes. The advancements in technology and the growing interest in space exploration have brought us to the brink of a new era. However, the allure of Mars is matched by its perils. Unlike Earth, our planetary neighbor is a hostile and unforgiving world, where even the simplest human needs, like breathing and staying warm, become daunting challenges. The environment is harsh, with extreme temperatures and frequent dust storms. Venturing beyond Earth's protective atmosphere and venturing into the Martian wilderness is not merely a giant leap for mankind, it's a perilous tightrope walk on the edge of survival. The journey itself is fraught with dangers, and the destination is no less treacherous. This essay delves into the formidable dangers awaiting astronauts on Mars, exploring the very real threats that could prove fatal in the blink of an eye. The risks are numerous and varied, each presenting unique challenges that must be overcome. From the invisible menace of radiation to the suffocating lack of breathable air, we will unravel the dangers lurking on this alien world. The thin atmosphere offers little protection from cosmic rays, and the lack of oxygen makes every breath a struggle. By understanding these challenges, we can better appreciate the immense task ahead and the critical importance of developing innovative solutions to safeguard future Martian explorers. The work being done in labs and training centers around the world is crucial to our success. For the dream of living on Mars to become a reality, we must first conquer the hazards that stand in our way. Only then can we hope to build a sustainable presence on the red planet and unlock its mysteries. One of the most insidious threats to human life on Mars is invisible to the naked eye radiation. This silent menace lurks in the form of cosmic rays and solar flares, which are omnipresent in space. Unlike Earth, which boasts a protective magnetic field and a thick atmosphere, Mars offers little shielding from the constant bombardment of cosmic rays and solar flares. The red planet's thin atmosphere is insufficient to block these harmful particles. These high-energy particles can penetrate human tissue, damaging DNA, and increasing the risk of cancer and other deadly diseases. The potential for long-term health issues is a significant concern for space agencies. Astronauts on a Mars mission would be exposed to radiation levels far exceeding those experienced on Earth, even during short trips. The lack of natural protection on Mars makes this a critical issue. The longer the mission, the greater the accumulated dose, and the more significant the health risks. Prolonged exposure could lead to severe health complications over time. Even with advanced shielding technology, it is impossible to completely eliminate radiation exposure during a Mars mission. Engineers are continuously working on improving these protective measures. The effects of radiation can be subtle and slow-acting, with symptoms potentially taking years or even decades to manifest. This delayed onset makes early detection and prevention challenging. This makes it a particularly dangerous threat, as astronauts may not be aware of the full extent of their exposure until it's too late. Continuous monitoring and health assessments are essential to mitigate these risks. While radiation poses a silent long-term threat, the lack of breathable air on Mars presents an immediate and deadly challenge. The Martian atmosphere is incredibly thin, about 100 times less dense than Earth's, and composed primarily of carbon dioxide with only trace amounts of oxygen. For humans, breathing this thin carbon dioxide-rich air is impossible. Without a constant supply of oxygen, an unprotected human would lose consciousness within minutes and succumb to asphyxiation shortly after. This means that astronauts on Mars would need to rely entirely on life support systems, both within their habitats and during extravehicular activities. Any failure in these life support systems, whether due to technical malfunction or human error, could have catastrophic consequences, quickly turning a routine spacewalk into a desperate fight for survival. The Martian climate is another formidable obstacle to human exploration. With an average surface temperature of about -63 degrees Celsius, Mars is a much colder world than our own. However, temperatures can fluctuate dramatically depending on the time of day, season, and location. At the equator, temperatures can rise above freezing during the Martian summer, but plunge to a bone-chilling -140 degrees Celsius at night. The polar regions are even colder, with temperatures rarely exceeding -150 degrees Celsius. These extreme temperatures pose significant challenges for both human physiology and technology. Exposure to such cold can quickly lead to hypothermia and frostbite, while the intense cold can also damage equipment and disrupt critical life support systems. Section 5. Starvation and dehydration, Martian resource scarcity. Surviving on Mars isn't just about overcoming the environmental hazards, it's also about securing the essential resources for human life. Food, water, and breathable air are not readily available on Mars and would need to be either transported from Earth or produced locally. Transporting large quantities of supplies to Mars is a logistical nightmare, requiring massive rockets and complex supply chains. While some resources like water ice may be found on Mars, extracting and processing them into usable forms will require advanced technology and significant energy expenditure. Any disruption to these supply lines, whether due to launch delays, equipment failures, or unforeseen circumstances, could leave astronauts stranded on a barren world with dwindling resources, facing the grim prospect of starvation or dehydration. Section 6. Toxic terrain, Martian soil hazards. The Martian soil, known as regolith, poses another unique challenge to human exploration. This fine powdery dust is not only abrasive, but also contains high levels of perchlorates, toxic salts that can interfere with thyroid function and pose other health risks to humans. This toxic dust can easily cling to spacesuits and equipment, finding its way into habitats and potentially contaminating air and water supplies. Long-term exposure to perchlorates could have serious health consequences for astronauts, affecting their metabolism and increasing the risk of certain cancers. Developing effective methods for removing and mitigating the risks posed by Martian dust is crucial for ensuring the safety and well-being of future explorers. Section 7. The psychological toll, isolation and confinement. The physical challenges of surviving on Mars are undeniable, but the psychological toll of such a mission should not be underestimated. Astronauts on a Mars mission would face months or even years of isolation and confinement, living and working in cramped quarters with limited social interaction, and facing the constant stress of living in a hostile environment. The lack of natural light, the monotony of the Martian landscape, and the constant awareness of being millions of miles from home can all take a toll on mental health, potentially leading to anxiety, depression, and other psychological problems. Maintaining crew morale and psychological well-being during long-duration space missions is crucial for mission success and the safety of everyone involved. Developing effective countermeasures to combat the negative psychological effects of isolation and confinement is an ongoing area of research. Section 8. Technological failures, the fragility of life support. In the harsh and unforgiving environment of Mars, human survival hinges on the reliable functioning of technology. Life support systems, spacesuits, communication arrays, and a myriad of other complex machines stand as the only barriers between astronauts and certain death. A single critical failure in any of these systems, whether caused by equipment malfunction, human error, or an unforeseen event, could have catastrophic consequences. Imagine a tear in a spacesuit during an EVA, a power outage disrupting oxygen production, or a communication blackout severing the lifeline to Earth. The remoteness of Mars further exacerbates the risks, as any rescue mission would be years away, leaving astronauts to rely on their own ingenuity and limited resources to survive. This underscores the paramount importance of redundancy, robust design, and rigorous testing for all mission-critical systems. Section 9. Conclusion. Overcoming the challenges for a Martian future. The dream of sending humans to Mars is a bold and inspiring one, but it is a dream tempered by the sobering realities of the red planet's harsh and unforgiving nature. The surface of Mars is a desolate and challenging environment, with extreme temperatures and a thin atmosphere that offers little protection. From the invisible threat of radiation to the psychological strain of isolation, the dangers facing Martian explorers are numerous and potentially deadly. The long journey to Mars, lasting several months, adds another layer of complexity and risk. However, these challenges, while daunting, are not insurmountable. With determination and collaboration, we can find solutions to these problems. Through continued scientific research, technological innovation, and a spirit of human ingenuity and resilience, we can develop the knowledge, tools, and strategies necessary to mitigate these risks and make human exploration of Mars a reality. The advancements we make in space technology will also benefit life on Earth. The journey to Mars will be fraught with peril, but the rewards, both in terms of scientific discovery and the expansion of human knowledge and presence in the solar system, are immeasurable. The potential for new discoveries and the inspiration it provides to future generations cannot be overstated. By confronting the challenges head-on, we pave the way for a future where humanity can not only visit Mars, but call it home. This vision of a multiplanetary existence is within our reach, if we dare to dream and work together.